Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Hi, Dr. Zuhi here, and this is for the course of EPF3108 Mass and Energy Balance. In the previous lecture, I already explained about the process and process variables. So today we are going to start with the first process variable, which is the temperature. In terms of the definitions, temperature is a measure of the energy, mostly kinetic, of the molecules in a system. Imagine molecules in a system got some energy. In terms of kinetic energy, the molecules will vibrate, and that vibration will produce heat. Equipment to measure temperature such as the thermocouples, radiation thermometers, field thermometers, and so on. In terms of how to measure the temperature, it can be either in the relative scale or in the absolute scale. Relative scale referring to the Celsius and Fahrenheit, also for the absolute scale is referring to the Kelvin and Rankine. So what are the differences between both? When it's come to the absolute temperature, it has their 0 point at the lowest possible temperature believed to exist. This is based on the ideal gas law and the law of thermodynamics, in which the 0 Kelvin and 0 Rankine is believed to be the lowest possible temperature ever exist. And for Kelvin, the corresponded relative temperature is Celsius, and for Rankine is Fahrenheit. 0 Kelvin is referring to also negative 273 degrees Celsius, while 0 degree Rankine is also similar to negative 460 degree Fahrenheit. So now I would like to explain a little bit more about the degree of temperature and the unit degree. So these are two things: the degree of temperature and the unit degree, or normally just call it as the temperature difference, are two different things that you normally will find in any kind of problems related to temperature. So just going to write it here. Two things. The first one is temperature degree. The other one is temperature difference. Okay. Sometimes the temperature difference is acute with this triangle symbol, but in most cases it's just referring to the same unit as the temperature degree, which is the Kelvin or degree Celsius and so on. For temperature degree, this one is the specific temperature at the specific time. For instance, like if you were referring to the boiling point of water is 100 degrees C, that's the temperature degree. However, if you are referring to the difference of temperature at different time, for instance, like the oven is 100 degrees C 1 hour ago, and now the temperature has been reduced to 80 degrees C. So the temperature difference is 20 degrees C. So that's about the temperature difference, and we need to differentiate between both. And because in most cases this symbol is not been included to differentiate between the temperature difference and the temperature degree, therefore the proper meaning of the symbol, whether it's degree Celsius, Rankine, degree Fahrenheit and Kelvin, whether it's the temperature, degree temperature or the temperature difference, must be interpreted by us from the context of the equation or sentence that being examined. So it's up to us to differentiate between both, because we need to differentiate it in order for us to solve the problem related to temperature. I'm going to explain a bit more about the temperature difference. Okay, For temperature different, Kelvin scale is equals to Celsius scale, while for Rankine scale is equals to Fahrenheit scale, like this one. And it's a bit different if we were to convert, let's say 1 degree Celsius, we need to plus 273 Kelvin in order to convert to Kelvin, right? But for the temperature different, what we need to do is just the same. For the temperature different, let's say 20 degrees C temperature different, will also have a similar value at 20 Kelvin. I'm going to give you example. Let's say 100 degrees Celsius, and then we reduce the temperature to 80 degrees Celsius. So the temperature difference is 20 degrees Celsius. This is the temperature difference. Well, this and also this are the temperature degree. If we want to change this degree Celsius, let's say to Kelvin, so 100 we need to plus, by according to this equation, we need to plus 273 is going to be 373 Kelvin, and 80 if you were to plus 273 is going to be 353 Kelvin. So from 373 minus 353 Kelvin, the temperature difference will also be 20 Kelvin. So this what it mean by the temperature difference in Celsius is also equals to the temperature difference in Kelvin, while the temperature degree in Celsius is not equals to temperature degree in Kelvin. So you need to differentiate between the temperature degree and temperature difference in order for you to solve any equation or any problem related to temperature. And this also same if we were to convert from Rankine to Fahrenheit. However, if we want to convert from, let's say, temperature difference in Celsius to the temperature difference in Fahrenheit, what we need to do, we need to times 1.8. And from Kelvin to Rankine also we need to times 1.8. This is for the temperature difference. Okay, this is for the temperature degree, where this is these are some of the formula that you can remember and try to understand it in order to convert, let's say, from Fahrenheit to Rankine, from degree C to Kelvin, degree C to Fahrenheit, and degree C to Rankine. What you need to do is just to use this formula. Can you see here, from Fahrenheit to Rankine, there's no multiplication of the temperature difference because of the same same system of unit. However, from, let's say, from SI unit, degree C to Fahrenheit, you need to times 1.8 plus 32, and from degree C to Rankine, you need to times 1.8 plus 460 plus 32. So try to understand how this formula has been made and where it came from, and we try to also use it in the example given later. So let's just start by doing some example here in terms of the temperature conversion. Okay, so the question asks to convert 100 degrees C to Kelvin, Fahrenheit, and also Rankine. My question is whether this is a temperature degree or a a temperature difference. So which one? This is a temperature degree because we don't have any difference in terms of temperature. So it's just straight away using this formula in order to convert that degree C to Kelvin and so on. So let's just do it together. Okay, for the first one, T Kelvin is equals to 100 degree C plus 273, which is equals to 373 Kelvin. Okay, for Fahrenheit, T Fahrenheit 100 degree C, you need to times 1.8 plus 32 and it's equals to 112 degree Fahrenheit. And lastly, for Rankine, for the temperature of degree Rankine 100 degree C times 1.8 plus 460 plus 32 and it's equals to 672 degree Rankine. Be alert here that for all the unit here, the Celsius have this degree symbol, Fahrenheit and also Rankine also have the symbol of degree. However, for Kelvin it doesn't have the degree symbol here, so it's just something that you should also aware when you write down the units. So this is a very straightforward example for temperature degree conversion. Let's just go to the next example. So the next example is about the temperature conversion to the thermal conductivity of aluminium is 32 degree Fahrenheit. At 32 degree Fahrenheit is 117 BTU per hour feet square degree Fahrenheit per feet. Find the equivalent value at 100 degree C in terms of BTU per hour, feet, K, Kelvin and feet. So here the first question asks whether this is a degree, temperature degree or temperature difference. What do you think? Well, one of the way to see whether it's a temperature difference or not is by looking at the units. If it's come with a various unit like this one, this would definitely is a temperature different, not a temperature degree. If temperature degree is going to only have the unit of temperature such as Kelvin, Fahrenheit or Rankine. However, if it's something to do with temperature difference, so the unit will be in various. So for this one, what we need to do is first looking at the value of Fahrenheit to degree C. Okay, so 32 degree Fahrenheit is equals to how many degrees C? Well, actually after doing the conversion, we know that 32 degree Fahrenheit is equals to 0 degree C. So we just going to straight away convert this temperature difference. We don't have to change anything. So now what we going to do, because this is not to convert from Kelvin, from Fahrenheit to Celsius, but from Fahrenheit to Kelvin. So, and this is the temperature difference. So just going to I'm going to show you on the way to answer it. I like to draw a long line here so that we can differentiate between different section. So 117 BTU per hour feet square. What else? And Fahrenheit. And then the Fahrenheit and another feet is here. So this is the unit of that thermal conductivity. So what we want to do, we don't want to change any other unit. We just want to focus on the temperature unit here. So from we are referring back to the temperature difference equation here. From if you want to convert from the SI unit to the English unit, what we need to do is to either multiply by 1.8 or we need to divide by 1.8. So same goes here. For this one, what we need to do is to put 1.8 degree Fahrenheit equals to 1 Kelvin, and that's it. You don't have to do any other things, just like that, so that this can be cancelled. And cancel, and then you're going to get the final answer with 210.6 BTU per feet hour feet square Kelvin. So this is the final answer. And you can see that why it's really important for you to identify whether the question is asking about the temperature degree or the temperature difference is the way we solve the problem. For temperature difference, it's just a matter of either we're just going to multiply by 1.8 or we divide by 1.8. It depends to whether we change from English unit to the SI unit and vice versa. For the temperature degree, you need to follow these equations. It's a bit longer compared to the temperature difference type of solutions. So let's just go to another example. This is a bit long example here, but it's okay, we're going to do it together. The heat capacity of sulfuric acid in a handbook has the unit of joule per gram mole degree Celsius and is given by the relation here. So this is the heat capacity, we have the numbers and also T here, where T is expressed in degrees Celsius. Okay, so modify the formula so that the resulting expression has the associated unit of BTU, pound mole, Rankine, and temperature is in Rankine. Okay, so now we try to understand the question first, whether this is a temperature degree or a temperature difference. What do you think? As I said before, it's something to do with a lot of units, multiple units here. It should be something related to temperature difference. However, if we look back into the question here, is also asking that T is in Rankine. So what we need to do we need to do two steps. First, to solve the T to from degree Celsius to T Rankine, and this is the first step, and the second step is to convert the temperature difference. Okay, so that's mean for this question, this first step is temperature degree type of solution, and for the second step is going to be the temperature difference. So for this question you need to do both. So it's okay, I'm going to show you how to do it together. Okay, so the first step, substitute for T in degree Rankine. So specific heat capacity, the symbol is CP 139.1 plus 1.56 times 10 power of negative 1, and this is where the conversion need to be done, where if you were referring back, we are now because this is a question about the temperature degree, so we are referring to this equation from degree C. We need to change to Rankine, so just going to use this kind of equation here. So it's gonna be T degree Rankine minus 460 minus 32 times 1 over 1.8. And how I got this is based on the equation in the previous slide, where R is equals to T Celsius times 1.8 plus 23 plus 460. So we just going to change this to, it is going to do it here, where T degree C is equals to this is just a matter of rearranging back. T Rankine minus 23 minus 46 divided by 1.8. This is actually coming from this, and that's what we are going to put in this bracket here, because the question asks so that the relation can be expressed in terms of T Rankine. So you need to solve this equation. At the end, you're going to get 90. You need to get 96.46 plus 8.6 times 10 power of negative 2 T Rankine. Okay, so this is the solution for the first step. Okay, then after that, the second step will be the temperature difference, and also some other unit that also need to be converted. Convert the desired temperature difference and other units as well. Okay, so the CP in terms of BTU, this is the unit of CP, BTU, pound, mole, degree Rankine. So So 96, we are just going to get the value from here, 96.46 plus 8.6 times 10 power of negative 2 T Rankine. And then we need to also convert other unit here, joule per gram mole degree C. This is the initial unit here, and we are going to convert first the temperature difference from degree C to 1.8 Rankine, and then 1 BTU is equals to 1055 joule, and then 1 pound mole is equal to 4,454 gram mole. All of this conversion unit, you need to refer to the conversion table that I already gave you. So at the end, the final answer will be 23.06 plus 2.0606 times 10 power of negative 2 T Rankine. So this is going to be the final answer here, and I know it's a bit tricky at the very beginning, but try to understand the question and try to also understand how I answer the question, where I already include the step here. The first step is to solve the temperature degree first here, and then the second step is to convert temperature difference and other units as well, in which we don't here we try to convert it according to the units that had been required. So at the end, you're going to get something like this. I really hope that you are going to also try this at home and try to understand it by experience doing it, and also try to get more example in the internet, on the internet, or in the reference book, to enhance your understanding about this particular topic. So that's for now. Thank you for watching this video. We'll see you again later. Bye bye. Assalamualaikum.